And welcome to, what is this? Our fourth day of Algebra 2 videos with Miss Faust. Again, I'm trying to work in some of your suggestions, trying to remember to talk loud. I have switched one of my pens out today. We'll see if that works well for us or not. So, today we're looking at lesson 1.1.3 part 2. We did start this lesson in the last set of notes, but this is a continuation. So we're going to be looking again at ways you can transform the graph of the function f of x. This time we're going to look at one more type of transformation. Last time we looked at shifts, horizontal and vertical, and reflections. Today we're going to look at what we call vertical stretches and shrinks. So what we'll have is, again, we'll start with some function f of x. And let me just remind myself how I did the notation for this last time. Yeah, so we'll use an arrow again. So f of x, instead of seeing f of x, we'll see a times f of x. So we'll see some number times f of x. And that's going to mean that we're going to vertically stretch the function by a. So what that looks like when our a is greater than 1, we get a stretch of the function. And when our a is, I want to say less than 1? Yeah, less than 1. Actually, when a is between 0 and 1, we get a shrink. If our a is negative, we get a stretch or shrink and a flip, and you'll see how that works in the examples. So if a is a fraction, basically, that's what we're looking at here. This is fractional values of a. We get a shrink, so our graph gets compressed. And if a is greater than 1, we get a stretch. So easiest to look at when we actually look at a graph. So take a minute and build yourself a little grid like I'm going to do here. Let's see. I'm going to put this, trying to decide how big I need this one. Probably bigger than I have it, but you know, if it goes off of the grid we have, that's okay. So the 4 points we're going to start with are 0, 0, and 4, 2, and 4, negative 2, and let's just use, let's see, how big did we get here? 7, so I'm going to go 7, 4. So 0, 0 to 4, 2 to 4, negative 2 to 7 and positive 4. So again, we just have some random function we're going to call f of x. So that's our original function. The idea here is that we're keeping it really general. Eventually we'll look at specific functions and how things change, but right now we just want some general random function. So we started with this f of x, which is these 4 points. Let me just write them out in case that's helpful. So 0, 0, 4, 2, 4, negative 2, and 7, 4 are the 4 points that we used. So what we're going to do then, for our first example of how to look at this, we're going to look at what 3 f of x would look like. And I'll do that in red. Hopefully you can see the red. So what we're looking at here is we're looking at what happens when we take our original function and we stretch it by a factor of 3. So what you want to think about is you always start from the x-axis and you're pulling all the points apart. So you're stretching it. We know it's a stretch because a is greater than 1. So we're stretching it away from the x-axis. So our 0, 0 point doesn't change. That one just stays right there. This point was 2 units up. But now if I'm stretching it by 3, I'm going to multiply 2 times 3, and I'm going to move it 6 units up. So that one ends up there. Connect those. So when I did 3 times f of x, just to keep track of the points again, sometimes that's helpful. 0, 0, 4, 6. This point is also going to get stretched down. So it was at negative 2. Multiply that by 3, I get negative 6. So that one's all the way down there. 4, negative 6. And then this last point, right now it's at 7 and 4. Again, I want to stretch it by 3, so I'm going to do 4 times 3, and 4 times 3 gives me 12. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12. So that one ends up way up there. Oh gosh, I wish I had a ruler, but I don't. So we're just gonna do this anyway. Okay, so you can see that green function, red function, we'll call the red function g of x, and we'll say that equals 3 times f of x. So we've just taken the original function, and we've stretched all the points out, so they're 3 times further away from the x-axis than they used to be. And what you might notice here, this point that was at 2 goes to 6. The one that was at -2 goes to -6. And the one that was at 4 is going to 12. So each time, what you're doing in all of this is you're multiplying the y coordinate by the value of a. So 0 times 3 is 0, 2 times 3 is 6, -2 times 3 is -6, 4 times 3 is 12. And just to look at one more example, this time I'm going to say h of x, and we're going to let h of x equal -1/2 f of x. So this time we have -1/2, so our a is here between 0 and 1, so we're going to shrink it instead of stretching it. And if we think again about taking all our y coordinates and multiplying them by 1/2, that's going to help us figure out where these points go. So 0, 0, well the y coordinate of that is 0. That's still going to be at 0, 0. So that point's getting hard to see, but that one will stay right there. 4, 2. So 4, 2, so the 2 gets multiplied by -1/2. Basically what I'm doing is I'm taking it and I'm making it closer to the x-axis by a factor of 1/2, and then I'm flipping it. So 4, 2 is going to go to 4, and 2 times -1/2 is -1, which is down here. My 4, -2, again the -2 gets multiplied by -1/2, and I get +1, so that goes to 4, 1, which is right there. And my last point, 7, 4, so 4 times -2, again is no, not 4 times -2, I'm sorry, 4 times -1/2 is -2. So 7 and -2 is right there. Da-da-da! And I have my h of x. So you can see that one's flipped from where f of x was. It goes in the opposite direction. That's because it's negative. It's also scrunched down closer to the x-axis because it's a factor of 1/2. Okay, so go ahead and pause now if you need to copy that down, or maybe you want to copy it and then watch the video again and think about it as you do that. We have a little bit more to do, but I'm going to stop for 1 second and I'll be right back with you. Back again, and you can see I've taken a moment and drawn in a new example. We're going to do a couple more transformations. I just wanted you guys to see a few more examples of this. So if you want to pause now, write example, draw this graph. The points are -3, 3, 0, 0, and 3, 3. And we're going to look at a couple more transformations on those. So stop if you need to, and then when you're ready, come on back. So g of x first, and we're going to let g of x equal 2 times f of x. So again, we're just looking at a stretch here, a vertical stretch with a factor of 2. Some people go straight to the graph and draw the graph first. Others think about the points first. Remember, if you're thinking about the points, we're multiplying all the y values by 2. So I'll do the points first on this one. Maybe the next one I'll do the other way. So -3, 3. So the -3 stays the same. 3 times 2 is 6. 0, 0. The 0 stays the same. 0 times 2 is 0. And 3, 3. So the 3 stays the same. 3 times 2 is 6. If you do it that way, then you can go from there to plotting the points. -3, 1, 2, 3, 4, 5, 6, 0, 0, and 3, and 1, 2, 3, 4, 5, 6. So notice how that stretches the graph away from the x-axis. Second one we're going to look at, and I hope this is a pen you can see. I know you'll tell me next time, though, if it's not. So h of x, we're going to call h of x -3 f of x, and we're going to add another transformation to this one. We're going to make it -3 f of x plus 2. So what that's going to do, when we have a combination like this, we want to do, think of order of operations. So this -3 times gets done first, and then we add the 2 at the end. So we're going to do the stretch first. Ooh, I forgot to move the cursor. So sorry. Okay, now he's gone. Where was I? -3 times the y values first, and then up 2. So this one I'll do the opposite way. I'll do the points first, and then, I'll do the graph first, and then write the points. So -3, 3. So we're multiplying the y coordinate by -3. Lots of 3's, I know. So we flip it. That makes it negative, and then we want to stretch it. So we flipped it, and then we need to make it 3 times farther away. So now it's 3 away. 3 times farther will be 9 away. So initially it would go right there. But because we have this +2 at the end, that shifts it up 2. So we flip it and stretch it, and then we shift it up 2. So it ends up there. This I leave as like a practice point, right? Because that was part of it. But then it got shifted up 2. I know that's really small, but you can see it if you need it. If not, that's okay too. 0, 0, so this point doesn't go anywhere when we stretch it because it's already on the x-axis, but it will go up 2. So that 0, 0 is going to go up 2 and end up right there. So I'm going to connect those like that. And then the last point, this 3, again, because we have a -3 here, we're going to flip it to -3, and then we're going to multiply it. So we make it 3 times as far away. So 3, 6, 9. But again, we have to go up 2. So that's like my practice point, but my actual point goes up 2 at the end because I have that +2 at the end. So my final graph would look something like that. Okay, so the points then, we can see, what are those points? -3, and then this would have been -9, but it went up 2, so it's -7. 0, 0 goes up 2 to 0, 2. And 3, 3 went down to 3, -9, but then it went up 2, so it goes to 3, -7 again. So hopefully you're getting a sense of what all the different kinds of transformations look like. We'll do a lot more practice with these in class, and we'll also do a little summary table in the next couple of days. This would be a good time, if you haven't already watched all the other videos, pardon the bell for a moment, to go back and watch all the other videos. And at this point, you should have finished assignments 1.1.1 and 1.1.2. So if you haven't finished those assignments, go back, work on those before you come to class next time. Thank you very much. Have a wonderful day. And